Okay. I wanted to make sure that people are okay with this. And when we wrote the original notes, when I originally printed the book, I didn't leave enough space at the beginning. And your guys' work is probably very crowded like mine was on here. As I was working yesterday, I realized, holy crap, I should have left them more space because even my screen filled up. So what I'm going to do here is on this blank page, which for you guys is page 67, I'm going to write out another radical equation. And we're going to do this with lots of room. We're going to do it nice and slow. It is y minus 1. Of course, it's already frozen when I write one line. Plus 7 equals 13. Now, for a moment, before you get into it, before you even start thinking about it, let's talk about what we need to have done here, right? Our goal with all algebra is what? Isolate the variable, right? So step one of all algebra is always isolate the variable, right? That's our goal. I shouldn't say step one. That's our goal. To do so, we perform inverse operations, right? I add, if I see add, I subtract. If I see multiply, I divide. If I see divide, I multiply. If I see subtract, I add, right? And we recently learned that if we see square root, we square. And if we see squared, we would square root, right? Okay. So to do this question, before yesterday, if this were in brackets, you deal with the plus 7 first, yes? Why? Because it's outside of the brackets, right? It's the furthest thing from the y. Everyone agree? Okay. So let's do that. Now, what is accomplished when we start with 7? We do minus 7, and I get root of y1 equals 6. Right there, I have accomplished the first step of radical equations, which is to always isolate any radicals. We got to isolate radicals. Cool? Everybody's happy with that? All right. Now, next thing. It's isolated. We don't like the radical, right? So we see a square root, so what do we have to do to get rid of it? Square it, right? Now, this is where it starts to get weird. When I square this side, what do I get? I get y minus 1, yes? And when I square this side, what do I get? 36. Now, once I have done this, I need to be aware of the possibility of extra answers. Why? What is it about squaring that means we have those possible phantom answers, which today I'm going to give you the proper name for those. But what is it about the squaring process that opens us up to extra numbers that might not be part of the original situation? Cool. Yeah, because the square root of anything is both the positive and the negative, isn't it? But in this original equation, way back here, there was nothing squared, was there? Right? So once we square something, now you guys are smart kids. Is taking something to the fourth power the same as squaring? Yes or no? Do you think it has the same properties? Does taking something to the fourth power introduce negatives? It does, doesn't it, Berg? Because negative 2 to the fourth power is positive 16, isn't it? And 2 to the fourth power is positive 16, right? What about taking something to the sixth power? Does that give us extra roots? Squared did, fourth did, does sixth? It will, won't it, Megan? Why? It's the same as 4 and 2 because it's an even, right? Because once you have two negatives, even numbers, you're going to get a positive back, right? What about odd numbers? No. We're okay if we have to use odd exponents. But anytime we got an even exponent, we got to be aware of these extra answers. And I'm going to write down the name right now while we're talking about it. Those extra answers are what we call extraneous roots. And you can see right there the word extra is in there. So now we've isolated our radicals. Then step 2 is eliminate our radicals. Now, we've only done square root, haven't we? So how do we get rid of square root? We square. What if we had a cube root? What would we do? Cube it, right? What if we had a fourth root? What would we do? Put it to what power? The fourth. So we eliminate using exponents. Right? So if it's a square root, we square. If it's a cube root, we cube. Cool? Now right here, I want to put a little star. We need to repeat I'm not going to write it. Repeat 1 and 2 until when? How many times do you think we have to do 1 and 2 in any given equation? When should we stop isolating radicals and eliminating them? Pardon me? Not quite. We're not that far, Jaskier, but it is close to that. When all the radicals are gone. We just follow the same rules. We repeat until all radicals are gone. And that's the biggest problem kids have with this. If a new radical shows up, they're like, I don't know what to do. But you do know what to do because you know you're supposed to isolate and eliminate. And then what's our third step? Then we just use algebra. And factoring. To get the roots. And then 4 is check. So, we are at a point now. Are all of our radicals gone? Yes. Is there any factoring I can do? Right here, where the red dot is. Is there any factoring there? Or is this just an algebra situation? It's just algebra, right? What are you going to do with that negative 1? Add 1. So y is going to equal 37. Have I solved using algebra? Yes or no? Yeah, because the y is by itself. So what's my last step? Check. Y is 37. So what goes right there? 37. What's 37 minus 1? Okay. What's the square root of 36? Is 6 plus 7, 13. So are we okay? And we had no extra roots. Everybody with me? Going slower with the day to think about it? Are people happier? All right, let's try one more. And I want the steps visible. So is it all right if I just erase this one so you guys can still see the steps? Okay. Okay, so this one is going to be the square root of 18 minus 3. And I'm going to change letters here. Does that matter? Of course not. 3b equals b minus 6. Is the radical isolated? Yes. Right? I want to change this slightly. Don't do what I'm about to do, just watch. What if it was 18 minus 3b plus 6 equals b? What would your first step be? Get that 6 over here. Now we're where we started, where you guys wrote. Everyone cool with that? Okay. What's our next step? Eliminate using exponents. So this is a square root, so we're squaring both sides, yes? So that's going to be 18 minus 3b. Now, what happens here? Is it b squared minus 36? No, what is it? No. It's b squared minus 6 minus 6 minus 12b plus 36. Why? FOIL. Right? That's why I do the polynomial multiplication. Now, did I square both sides? Have I introduced the possibility of bad roots? Extraneous roots? All right, now what would you do with that? I've still got to isolate my b's, yes? So these guys are no good over here, are they? So what do I need to do? Move them. If I move both of these guys, what did I leave over here? 0. Any b squareds? No, it doesn't change. What happens to that negative 3b when I bring it over to the other side? Positive 3b. So it's going to be minus 9b. What happens to that positive 18 when I bring it over to the next side? It's going to be minus 18. 36 minus 18 is what? 18. Now, do I know what to do with that? Factor. What are the factors? B minus 3 and b minus 6. Now, here is where you guys get in trouble because you don't understand what's happening here. Okay? All of you recognized the shortcut yesterday. The answers are 3 and 6, yes? The possible answers. I need you to know why. You need to know why. Can someone explain that? Why is it 3 and 6? It's all through your notes. But once you guys saw the shortcut, everybody stopped paying attention to why. It's important. One sec. Burke? I've got both of these things here and they equal 0, yes? What math is happening right there? Multiply. Max?
I was going to say, so you have b minus 3 equals 0 and
right.
b minus 6 equals 0, and then you factor to isolate the b, or not factor, you isolate the b, so you move negative 3 over to,
right.
So you have to add 3 to
so b equals 3 because I moved that over, and b equals 6 because I moved that over. Because if this is 0, then does it matter what this is? then I'm going to get 0 when I multiply them, aren't I? If this is 0, does it matter what this is? I'm going to get 0. So that's why this works. Now, do I have Do I have 2 possible answers? What are they? 3 and 6. What's my last step? Check. Where? At what point can I check? The very, very beginning. So I got to go way back up to here before I've squared and done anything, right? So we'll start with 3. What's 3 times 3? 9. What's 18 minus 9? 9. What's the square root of 9? 3. So when b is 3, and we'll do that one in red, when b is 3, this side of the equation is 3, yes? Because I only care about the positive root, right? Come to this side. What is 3 minus 6? Negative 3. Does 3 equal negative 3? No, of course not. So, is 3 okay? No. Let's check 6. What's 3 times 6? What's 18 minus 18? 0. What's b? 6. 6 minus 6 is what? 0. Does 0 equal 0? So is 6 okay? Yes. Why do we have to check both? Because it's possible neither one of them is the actual answer. Everybody cool? And the reason that neither one might be the actual answer is this. All of these things, if you put them on a graph, they make a U. And we're about to do this next unit. These answers are where that graph touches it's where the graph touches the x-axis. Oh, there we go. There and there. So it's possible that your graph never touches the x-axis. All right. Are people feeling a little better with this? Okay, now remember, I did tell you. Oh, yes.
I was just gonna ask if you do like a question where in the page reading before it said root x and then in brackets root x minus 7.
Yep.
Do like a question where it's root and then another.
Yep. I'm actually going to do 2 more here with you guys. Then we're going to go back to that one that I left you with for homework. So let's start with, I want to do one that works. So just give me a sec. Okay, so let's do this one. Square root x times x minus 8 equals 3. So now what Max is saying is he's saying, okay, well, I understand I got to isolate radicals. I understand I got to do algebra. I understand I got to factor, blah, 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 blah. But this one's weird. Why? 2 radicals, okay? So first thing to do is isolate how many of them? Look at what I wrote in red here. You repeat 1 and 2 until all the radicals are gone. So how many can we work with at any given moment? 1 at a time. So let's isolate one of these radicals. Does it matter which one we isolate? No, not really. But one of them is easier to work with. Which one? Root x. It's simpler, right? So if this root x was a 5, then I would divide by 5 to get rid of it, right? So we're going to divide by root x. Everybody okay with that? So what do I have now? What happens to these root x's? They're gone, and I have root x minus 8. Everybody cool? Equals 3 over root x. Now what? Now I'm going to square, because I'm working with this guy, right? So let's square them, which means I square this side, yeah? Okay, so what happens to this guy? What's on the left now? It's just x minus 8, right? I can't write yet because my pen is frozen. Oh, got it. Now, square this side. What's 3 squared? Over what? X. Oh, look, in this case, all of our radicals were eliminated in one shot. If we had a radical still, what would we do right now? If I was left with a radical somewhere in this, what would I do? If I was left with a radical in here still, what would I do? I would isolate them and eliminate them. Okay, so solve that for me. Again, you already know math. If I had 10 equaled 50 over x, what would you do? What would you do right here? Subtract 10 times 10. I would multiply by x, cancel them. Then I would get 10x equals 50. Then I would divide by 10, yes? So if you know how to do this, do you know how to do this? Yes. How do I get rid of that x in the denominator? Multiply by x in the denominator. What happens there? Cancel. If I multiply the right side by x, what happens over here? Same thing. X times x is x squared minus 8x equals what? 9, right? Okay. Now what? Move the 9. X squared minus 8x minus 9 equals 0. Now what? Factor it. What is it? X minus 9, x plus 1. What are my possible answers? 9 and negative 1, correct? Everyone agree? Okay. Now, did I square both sides at any time? Yes. So did I open the possibility for extra roots? So do I have to check? Yes. If I didn't square both sides, I would be okay, right? So let's check. What is the square root of 9? 3. What is 9 minus 8? 1. What's the square root of 1? 1. What's 3 times 1? 3. Does 3 equal 3? Yes. So 9 is okay. Now let's check negative 1. What's the square root of negative 1? Doesn't exist. So is 1 a possible answer? No. Everyone see how it works? Now, Max, I know you're worried about extra radicals, right? That was what that question was for, yeah? You wanted to get rid of 2 radicals. And you noticed that both radicals disappeared in one go. What do you think happens if both radicals don't disappear in one go? Do you want to do one of those, or do you guys want to try one by yourself? Or should I do one of those here? Want to do one of those here? By yourself? Okay. Start on page... do we want to go back to that one bit of homework I gave you? Now remember, that was supposed to not work. There's a reason I gave that to you. So you got to here, you squared both sides. So this ended up being 49 plus 14 root 3x plus 3x. Yes? Everybody with me? That's what happens when I FOIL that out. Is everyone cool? Now, this is actually a good question because it left us with a radical, didn't it? Right? Because I still have a radical. So now what should I do? I should isolate them, right? So let's isolate that radical. So that's going to give me 14 root 3x equals 2x minus 45. Is everybody cool with that? I just moved everything over and isolated the radical, right? Now what? Square again, right? So that is going to be 14 times 14, which is 196, times 3x, yes? Which is 588x equals, what do I got to do to this side? Square it. 4x squared minus 180x plus 2025. Everyone okay? I just did the FOIL in my head. Is everyone okay with that? Okay. Now what would you do? You'd move the 588. So that's going to be minus 768x plus 2025. Now what would you do? Factor. Right? Well, first you try to simplify, but you can't, can you, Bert? Because 4 won't go into 2025. So you'd factor it. I'm going to tell you right now, if any of you did this and you tried to factor it, you would find it didn't factor. Okay? And the reason I gave this to you last is because I wanted to show you, I was going to show you what the next step is, because the next step is our next unit, and this is the end of this unit. You follow me? But I wanted everyone to be able to get to there. If you didn't try this for homework, do you see what we did? Okay, now, when we get to here, if it doesn't factor, does not factor, then you get a new math tool. And that new math tool is split into two. You either get your graphing calculator, which I'm going to teach you how to use if you don't, or you get something called the quadratic formula, which will solve this for you. That was the whole point of that question. Everybody good? This is next unit. To here is this unit. Okay? All right. So now you should feel pretty confident with page 65. Do 65, 1, 2, 3, 4, 5, 6. Don't attempt this. Well, attempt this at the bottom. Inspection means just by looking. Okay? This is a little bit misleading. When I say don't do any work, I mean don't do any of the steps. Don't isolate radicals. Don't square. Right? Just something you can do in your head right away. See if you can figure this out. Okay? Everyone cool? All right. So you try 1, 2, 3, 4, 5, 6. That should take us to about 9 o'clock. Right? Then I would like to go do our test review. because you're having a test on factoring and radicals. Not radicals, radical equations. Factoring radical equations in the near future. Okay? I don't know if I'm going to make it tomorrow, because tomorrow is short days. But I might, because I don't think I'm going to give you much factoring on it. I think I'm going to put on more of these. Okay? So go, you can work together. Just remember, isolate, square, isolate, square, isolate, square, factor, and algebra. Oh, restrictions. We remember about restrictions, right? As long as you remember they're there, I'm happy. Just do the radical stuff. You understand what I'm saying? You don't get restrictions? Anything under a radical sign can't be negative. So you're just doing a grade 9 inequality. Okay. How many people would find it beneficial for me to do 1 and 2 in a few minutes to make sure you're on the right track? Okay. Okay, I'm going to do this a little differently because this is not notes anymore. I'm going to ask you guys, what don't you like about number 1? And you can't answer, Dina, because we just talked about it. What don't you like about number 1? You don't like a negative radical, yes? This bothers my good friend Max because he knows he has to isolate it, but he sees that it's negative. So it's not enough to just move the 2, because if you move the 2, that radical still has a negative in front of it. So let's move that whole radical over here. Then what will happen to that negative? It'll be positive. So I will still have root. Does that negative change? No. Negative 6m. Now, if I move this radical over here, what was already over here? That negative 5. So that radical's not isolated, is it, Sukpal? No. So I got to move this over here. What happens to that negative 5 when he comes over here? Positive 5. What was already over here? Positive 2. So what does that give me? 7. Now, is my radical isolated? Yes. So what's my next move? Square it. What's on this side? Not 6m. Negative 6m equals what? 49. Now, are all our radicals gone? And there's no factoring, so we're doing algebra, yes? According to algebra, what's our last step? Divide by negative 6. So m equals negative 49 sixths. Now that looks weird, doesn't it? And you're stressed, aren't you? Because you think you have done it wrong, don't you? But you have not. Because you can check. Negative 5 equals 2 minus the square root of negative 6m. What is m now? Negative 49 sixths. What do two negatives do when they multiply? Make positives. And what does 6 do when it multiplies sixths? Cancels. So what am I going to have under there? 2 minus root 49, yes? What is the root of 49? 2 minus 7. What is 2 minus 7? Does negative 5 equal negative 5? So did we do it right? Even though it looks frightening, and all of you, as soon as you saw fractions, you had a little mini throw up. Yeah, right? Or a little twitch. Not all of you, but a great many of you, as soon as you saw that fraction, your first reaction was you did something wrong. Wasn't it? Be honest. It was. But you needn't feel that. That's why I said have faith. When you actually see it written out, it makes perfect sense, doesn't it? Square it. Okay. Opposites, opposites, opposites. Just all that same opposite algebra work that you've been doing since Mrs. Bad Crumble first said, if I have 3 apples and there's 10 apples in the box, I take 3 of them. How many apples are left for Sarav? That's algebra. How'd you know? Because 10 minus 3 is 7. Okay? Try number 2. Go, diddly, oh. What? Making fun of me again? You notice how I never make fun of you. Sarav, I'm going to start choosing a new long syllable funny sounding word every day. And I'm going to use them, and you're going to keep making fun of me by saying them in that voice that you say is my voice. But you know what? By using them that often, you're actually going to start using them in real life. Then you're going to sound super smart. So I'm actually doing you a favor. Unless, of course, you start using them wrong. Like you hit your thumb with a hammer and go, oh, doppelganger. It's not a swear word. No, is that a graphing calculator? It's actually more closer to a computer than it is a calculator. This machine is more powerful than the computers that were on the Apollo missions to the moon. Yes. I know. Yes. And you guys complain about the math we make you do with that. Those dudes went to space with less than that. Those dudes went to space with less computing power than most of your digital watches. It is very cool, Burke, but it is also very sad that when we present you guys with this, are people ready to see number 2? Are people ready to see number 2? 1 minute? Okay. I got your minute. You two are funny. Ugh. And now we check. Big party in the front corner.
So is it just 37 minus 1? 36. 36 is 6. 7, 4 times 6. Oh, negative. It needs to be negative. No.
Yo. Is it time to do number 2? All right. So, what do people want to do first? Get rid of the 7? You could get rid of the 7. So then you would have negative 4 root 2x minus 1 equaled 24. Yes? Now what? Divide by negative 4 because you want to isolate the radical. The square root of 2x minus 1 equals negative 6. Now what? Square both sides. 2x minus 1 equals what? 36. Now what? 2x equals 37. Now what? X equals 18.5. Yes? Everyone agree? Okay, let's check. As soon as it shows up. What is 18.5 times 2? 37. What's 37 minus 1? 36. What's the square root of 36? 6. So I have negative 7 minus 4 times 6. What's that? Minus 24, which is negative 31. Does negative 31 equal 17? No. So does this question have an answer? No, because that root is extraneous. It doesn't exist. Which means if I put this on a graph, would the line ever cross the x-axis? No, because there is no root. Understand? Everybody good? Okay. Now, how did I know that there might be an extraneous root? Because I had to square both sides, didn't I? If I didn't square it, I could not have solved this. Everybody cool? All right. Number 3. Keep going. Work it, girl. Number 3 is deadly, but it looks a lot like number 2. Burke, what is the first thing you would do with number 3? You would move that 3 because that is something that is in the way of the radical being isolated, isn't it? So when that 3 moves over here, what happens to it? It becomes positive. What is 12 plus 3? 15 equals 5 root 8 minus x. Now what? Is that radical isolated? No, there's still a times 5 in the way. So what do? Divide by 5. What happens to those 5s? Cancel. What do I have to do to this side? Divide by 5. So now I have 3 equals the root of 8 minus x. Is that radical isolated? Can I now get rid of that radical sign? What gets rid of a radical sign? Squaring. If it's a square root, right? Cubing if it's a cube root, so on, so on, so on. So if I square this side, what do I got on the right? 8 minus x. If I square the right side, what do I do to the left? Square it. So what is on the left? 9. What do I do to that 8? Minus 8. 1 equals negative x. Is x isolated? No! What's in the way of x being isolated? Negative. So I divide both sides by negative 1. Negative 1 equals x. Am I done? I'm done the algebra. Did I square both sides? So is it possible that's not a right answer? So let's check. Go back to the beginning. What is 8 minus minus 1? 9. 8 plus 1. What is the square root of 9? 3. What is 3 times 5? 15. Is negative 3 plus 15 12? So is this the right answer? Yes. Gouda? Oh, it just looks like a bean. Anybody ready for number 4? Oh, this time we did. Yeah, it worked that time. See? I must have been speaking better. Is that radical already isolated? So do I have to do anything? I just got to square it. Some of you are going to screw this up, though, aren't you? When I square this radical, does the radicand change? No. So I get m squared minus 3 equals 25, right? Now what? Algebra. M squared equals what? 28. Last step. Square root. M equals square root of 28. Could I leave it like that? Yeah. Is that the best way to leave it? Or could I do one more thing? That's 4 times 7, isn't it? So this is 2 root 7. Now, do I check? Yep. Square root of 28 goes right there, yes? What's the square root of 28 squared? 28. What's 28 minus 3? 25. What's the square root of 25? 5. Does 5 equal 5? So is that correct? Yeah. Sure. You betcha. Everybody good? Starting to feel comfortable? It just needs practice, right? You just got to do it a few times and have faith in the fact that what your math teachers have been teaching you all the way along in algebra is still works. 5. Frightening. Hey, Sarav, is the radical isolated in 5? Yeah, so I can just go straight to doing what? Squaring. Uh-oh. What do I do now? X squared plus 12x minus 64 equals what? 0. Now what? Factor, factor, factor. I need numbers that multiply to negative 64 and add to 12. What are they? Negative 4, positive 16. Now it's better than hitting him. What are my possibilities? 4 and negative 16. Do I check them? Of course I do. What's 4 squared? 16. Plus 48 is 64. Right. What's the square root of 64? Does 8 equal 8? Yeah, so 4 is good. What's negative 16 squared? 256. Right. What's 12 times 16? 192. Right. 256 minus 192? 64. Right. Square root of 64? Does 8 equal 8? So are they both okay? Yeah. And then number 6 is this kind of the second hardest one you can get. What's ugly with 6? Pardon? There's an X on both sides. And what else is ugly with 6? What do I got to do with that? Minus 5. So I got root 3x minus 5 equals x minus 5. Okay, is my radical isolated? So can I square now? And here's where you're going to make your mistake. When you square this, what are some of you going to forget to do, even though I've told you a million times? Foil. Some of you are going to tell me that that is x squared plus 25. Some of you are going to do that on your test in a couple of days. Please don't be one of those some. Right? Squaring a binomial is FOIL. That's why we practiced it again at the beginning of this unit. So that is x squared minus 10x plus 25. Now what? Yep, collect your like terms. 0 equals x squared minus 13x plus 30. Now what? Factor, factor, factor. Got to multiply to positive 30, add to negative 13. What is it? Negative 3, negative 10. What are my possibilities for x? X could be 3, x could be 10. What do I do? Check. What's 3 times 3? What's 9 minus 5? 4. What's the square root of 4? 2. What's 5 plus 2? 7. Does 7 equal 3? Yes or no? No. So is 3 allowed? No. Do I believe that 10 is allowed or do I check it? I check it. What's 3 times 10? 30 minus 5. Square root of 25. 5 plus 5. 10. X is 10. Does 10 equal 10? Last I checked. So is that a real answer? Yes. So if I were to graph it, the line would cross the x-axis there at 10. Everybody with me? All right. How are you feeling? All right. Now, let's do this last one, and then I'm going to give you guys, we'll write out our review for the test. Looking at this, looking at these, only something you can do in your head easily. What's the first thing you would do here? Move that 2. So you would end up with square root of 3y minus 1 equals 7. Is that possible? Can the square root of something be a positive number? So that's possible, right? Okay. What about this one? I would move that 9 to get 13 equaled m plus 6. Is that possible? All right, we could just solve that, yes? Okay, what about this one? Root x plus 8 would equal what? Negative 7. Is that possible? Why? Can't have a negative answer there, can you? So the only way we could do this would be to square both sides, right? And once we square, we are introducing the possibility of an extraneous root. This one's solvable, right? Right now. This one's solvable right now. Even if we square both sides, since it's not negative. But this one is guaranteeing us an extraneous root. Because as it is right now, before we square it, it's impossible. So once we square it, that opens up the possibility for an extraneous root. Even though we did that everywhere. But because this one starts as impossible, the only way we could solve it would be to get an extraneous root, wouldn't we? And then when we checked that root, would it work? If it's extraneous, would it work? The extraneous ones are the ones that don't work. So this one we can't solve, right? Everybody cool? Okay. Take a moment. Collect your thoughts. And if you're ready, you could flip to page 69 and we could talk about test reminders. Or we could do another couple of these. So what are our test reminders for this unit? 1. Polynomial multiplication. Multiplication. And that comes in 3 flavors, right? There's distribution. Somebody give me an example of distribution. What would that look like in math? Three x minus 7. What would the answer be? That's first flavor, flavor 1. That's vanilla, right? Let's move on to strawberry. Strawberry would be binomial distribution. What do we know binomial distribution as? What's its fun little name that you got for it? FOIL. Give me an example of it.
2x plus 4x plus 1.
And then if you were in my class, I gave you a real nice, easy way to do that. Do the first two, 2x squared plus 2x. Then do the second two, and make a new line, 4x plus 4. And then just add them up. You can do it in your head, great, or you can write it out like mine. And what's the third flavor? The complex, the chocolate flavor. Trinomials. And that's just an extension of FOIL, right? X minus 7, x squared plus 3x plus 4. You're just going to do one line, two line, three line, right? Gouda? Do I need to do that one, or is everybody cool? Okay. That was the first thing that's going to be on this test. Polynomial multiplication. Come on. Next thing that's going to be on this test. Factoring. Again, comes in three flavors. What's the first one? It's the easiest kind of factoring. Starts with a G, ends with an R, has greatest common factor in the middle. Greatest common factor. Well done. GCF. How do you do that? Find the greatest common factor, divide, rewrite. Right? So if I had 16x squared y to the fourth plus 32x y to the seventh plus 48x to the third y to the fifth, what would the GCF be? 16 x y to the fourth. 16x y to the fourth. Then I rewrite. Where does the GCF go? On the outside. What goes on the inside? He asked patiently. The answers. X plus 2y to the third plus 3x squared y. Flavor 1. Flavor 2. Trinomial, where a equals 1. That is x squared plus 7x plus 12. What's that? Multiply to 12, add to 7. What is it? I'll help you out. Flavor 3. Trinomial where a doesn't equal 1. So that's 3x squared plus 5, 8x. What do you do with that? You bring the 3 along. Oh, there it goes. Almost made it. So close. So very close. There we go. Multiply to fit in. Add to 8. What is it?
3 and 5.
X plus 3 over 3. X plus 5 over 3. Simplify your fractions. 1. Denominators go to the front. X plus 1. 3x plus 5. Done. And the fourth kind, flavor 4. Difference of squares. 9x squared minus 25y squared. What do I do with the first one? Square root. What is it? 3x. What do I do with the second one? Square root. What is it? 5y. Then what's the second binomial? Same thing, but minus. And then finally, diff of cubes. X cubed minus, let's go 27x cubed minus 8y cubed. Starts out with 3x minus 2y. Then 9x squared plus 6xy plus 4y squared. You have notes on all that. And then finally, radical equations. All that's on your next test. Remembering, of course, that the only thing that is new is that and that. Everything else you already knew before you got to grade 11. Or you should have. Should I do one more radical equation in this review for you right now? I got 4 minutes. Should I? All right, let me choose one to make sure it works. Because I'm bad at making them up out of my head. Let's do... Yo. What, brother? Okay. Talking to Mr. Radnai? Because it's all good. Let's do this one. Square root of z plus 5 equals the square root of 2z minus 1. Radicals on both sides. What do I do? Square both sides. So what do I get? Z plus 5 equals 2z minus 1. Now what? Algebra. Z equals 6. Check it. What is 6 plus 5? 11. Square root of 11. Can't do that in my head, so what's 2 times 6? What's 12 minus 1? 11. Does the square root of 11 equal the square root of 11? Done. Should I do one more? What? I don't think the test will be tomorrow. I think we'll have it Friday. But we're going to have to move on tomorrow. I'll do one more. Oh. Root of 5x minus 9 minus 3 equals the root of r plus 4 minus 2. Actually, that's your homework. The square root goes over the 9, and it goes over the 4. That's your homework. One question. I'm interested to see how many hands go up tomorrow when I ask. Word. I pretty much assume you're not going to be here at least 1 or 2 days a week, Sonia. No, it's okay. You don't need an excuse. You just need to be aware of the possible consequences of all these choices. That's all I'm saying. And since you are, I'm not worried about it because you're not worried about it. I don't need to worry about it because you don't worry about it. Okay?